Hello students, welcome to AIMS India online classes. So here we are going to discuss about chemistry chapter, that is acids, bases and salts. From this chapter in the previous sessions we discussed about different kinds of acids and their classifications and the different types of bases and their classifications we have seen. Now we are going to see about acid base indicators, means the substances which can recognize these acids and bases. So about this we are going to see in this session. A substance which detects the acidic or basic nature of another substances by change in color is called acid base indicator. Okay, some chemical substances are there, they can identify the other substances by changing its color, whether they are acids or bases. Such kind of substances are called acid base indicators. It is not advisable to taste any substance in the laboratory because it can be harmful. Yes, we told that acids are bitter in taste. Acids are sour in taste, whereas bases are bitter in taste. But in the laboratory, to identify whether the given substance is whether an acid or base, we should not directly taste them, because some chemical substances are there which are harmful to us. We should not taste them directly. First, we have to know the nature of those substances, then only we can touch them or we can taste them. Until and unless we know about those chemical properties of the substance, we should not taste them or we should not touch them also. So how to identify these acids and bases without tasting or touching them? For that purpose, we use some substances which give some color changes when they react with these acids or bases. Those substances are called acid-base indicators. So hence, acid-base indicators are used to check if a given substance is either an acid or a base. So how many types of these indicators are there? Yes, majorly these are based upon the sources from which these indicators are prepared. These indicators are classified into two types. They are natural indicators and synthetic indicators. So first let us go through these natural indicators. So the indicators that are obtained from naturally occurring substances are called natural indicators. Yes, from the natural substances some indicators are prepared. Those indicators are called natural indicators. For example, litmus, turmeric, China rose. These all are the some substances which are derived from natural sources or natural substances. So hence these are called natural indicators. Okay, first among them is litmus. Litmus is extracted from lichen. So it is like a fungi. Lichen is a composite organism. It consists of fungi and algae living symbiotic relationship. Okay, this contains some living organism like fungi and algae. From these, this litmus is extracted. So as it is having its origin from the natural substances, it is coming under natural indicators. Litmus is a natural indicator. Litmus is a purple colored liquid in distilled water. Litmus comes in the form of strips of two colors. Actually, after extracting this litmus from the lichen, it is made into from the solution of this litmus. They prepare some papers. Those are called litmus papers. These litmus papers are of two colors. They are available in two colors. One is blue color litmus, and the other one is red color litmus. So there are two colors. There are two colored litmus papers, blue color and red color litmus. Now with these different colored litmus papers, we can test acids and bases. Litmus liquid and litmus paper are used to detect the acidic and basic natures of substances. So the color of litmus paper in acidic solutions. Yes, when we dip a blue litmus paper into a red acidic solution, it turns into red color. Blue litmus paper turns into red when dipped in acidic solution. See, they have taken a blue litmus paper, they dipped in the acid solution, then it turns into red color. In this way, when this blue litmus paper turns into red color and dipped into a solution, then we can say that solution is acid. That solution is acidic in nature. In that way, we can identify the acidic solutions or acidic solutions by taking blue litmus paper as indicator. When you dip this blue litmus paper into some solution, if it turns into red color, then we can say that solution is acidic in nature. Okay. Next, the color of litmus paper in basic solutions. If if we dip red color litmus paper into basic solutions, it turns into blue color. Yes, if we take some red color litmus paper and if we dip into this base solution, it turned into blue color. So by this property, we can identify base solutions. If we take a colorless liquid, where if we without knowing its nature, if we take a redless paper and if we dip it into the solution, when it turns into blue color, then we can say the solution is basic solution. So in this way, we can identify acids and bases by using litmus papers. For detecting acids, we use generally blue litmus papers. For the detection of bases, we use red litmus papers. If we dip blue litmus paper into acid, it turns into red color. If we dip red litmus papers into bases, it turns into blue color. So what happens if you use the color in the reverse way? That means if you dip this red color litmus paper into acid, what happens? There will be no change in the color. It will be in red color itself. If it is blue colored litmus paper into base, what happens? Then also there will be no change in its color. It will be in the blue color only. Only blue litmus paper can show or can change its color when dipped in acids. And red litmus paper can change its color when dipped in base solution. Okay. In this way, litmus is used to detect or identify the acidic and basic nature of the substances. Next, one more natural indicator, turmeric. It is very familiar to us. Mostly in our homes we use in the domestic purposes in the food items. Turmeric. Turmeric is also a natural indicator. Actually, we know turmeric is of yellow color. Yes. Turmeric paper turns into red when it is dipped into basic solution. Turmeric paper does not change its color with acids. Yes. Turmeric paper can be used to identify bases. When this turmeric is mixed with bases, immediately it color changes to red color. When it mixes the acids, it won't show any color change anyhow, but it can show color change with bases. Okay. See here, they have taken turmeric water or the turmeric solution. If base is added to the turmeric solution, immediately it turns into red color. If an acid is added, its color won't be changed, it will be in the yellow color itself. So it won't show any change with acids, it won't show any color change with the acids. It can change its color to red when it is base is added to it. Okay. Magic with turmeric. Yes, we can do some color magic with turmeric. That is, take some turmeric powder, add a bit of water to it and prepare turmeric paste. Rub this turmeric paste on a white paper so that that white paper becomes red in color. Sorry, yellow paper, yellow in color. Now, draw a flower on that yellow paper with a pencil. Color the flower with soap water using a brush. Then you can identify that turmeric changes its color to red when soap water or lime water is added to it. So when you take lime water to draw a flower or some diagram, that changes immediately its color to red color. So even though we are writing with a colorless liquid, then after drawing it changes color to red color. You can see here. Okay. Why? Because here the soap water is basic in nature. We told that turmeric changes its color to red when it reacts with soap water or lime water, which is basic in nature. So when you write this soap water or lime water as a drawing or diagram, immediately the diagram turns into red color on writing with on writing the yellow colored turmeric paper. This is the reason why they use one familiar word with parani. I think you have heard this. Generally, ladies they use this parani to decorate their foot. What they do first, they apply turmeric to their foot completely. On that, they apply some soap water or lime water with some design. What happens immediately there? It turns into red color. Why? Because there this lime water or soap water which is containing base reacting with the turmeric which is natural indicator and then immediately converting into red color. So this is the reason they use it. Okay, turmeric is a natural indicator which shows color change with bases. It won't show any color change with acid. Okay, next one. Chain arrows. Chain arrows is also one of the natural indicators. Chain arrows solution gives a dark pink or magenta color with the acid and a green color with the base. Yes, it is a chain arrows. It is also used as a natural indicator. Generally, it's a solution. Chain arrows extract or solution will be light pink colored. When this is added to an acid, it turns into dark pink or magenta color. And when it is added to a base, its color changes to light green color. In this way, this chain arrows also can be used as an indicator and it is extracted from the chain arrow flowers and hence it can be called as natural indicator. So these chain arrows gives magenta or dark pink color with the acids and a light green color with the bases. Okay, now what we have seen about natural indicators we have seen. One of them is litmus. Litmus is extracted from lichen, which is natural, which is having natural sources like fungus and algae. So this natural litmus is available in two colors on the papers. One it is called red litmus, other one is blue litmus. This red litmus turns into blue color when dipped in bases and blue litmus when turns into red color when dipped in acids. So in this way it shows color changes and hence acids and bases can be identified. Now second one, turmeric. Turmeric is also one of the natural indicator which shows its color change with base only. It won't show any color change to acids. Okay. The next one I just now have seen about chain arrows. These are all coming under natural indicators because these are having their origin or sources from the natural substances. Okay. Now let us say about synthetic indicators. Indicators that are made in the laboratory are called synthetic indicators. Yes, the chemical by using chemical substances, these indicators are prepared in the laboratory and hence they are called synthetic indicators. For example, methyl orange, phenolphthalein, etc. These all come under synthetic indicators or man-made indicators because they are prepared in the laboratory. First, let us say about methyl orange. It gives pinkish red color with acidic solution and yellow color with bases. Yes, when this actually it's a color in the name itself it is a orange. This methyl orange is one of the organic substance which is in the orange color. It is light orange colored solution. When this added to an acid, it changes to dark red color or pink, dark pink color or red color you can say. It changes to red when it is added to acid. And when this methyl orange is added a few drops to the base, immediately its color changes to yellow color. So by these indications, color changes, we can identify acid and base by using synthetic indicator methyl orange. Okay, one more synthetic indicator is here, that is a phenolphthalein. It is also a acid base indicator, synthetic indicator. It is a colorless acidic solution. Actually, it is a slightly acidic in nature and it is a colorless solution. Whereas methyl orange in light orange color. It turns into pink in alkali solutions. What did we say? Alkali solution means alkali means base. So it turns into pink color when it reacts with bases. It won't show any color change with acids. Phenolphthalein will not change the color of acid. It will be colorless only. But when we add few drops of phenolphthalein to base solution, immediately it turns into pink color. Okay. So these two are synthetic indicators, methyl orange and phenolphthalein. Methyl orange is present in light orange color. When this methyl orange is added to an acid, actually acids will be colorless, transparent they will be solutions. So when you add few drops of this methyl orange to acid solution, immediately the color of acid solution changes to dark pink or red color. In the same way, if we add few drops of this methyl orange to uh, base solution or alkali solution, immediately the color of the base will change to yellow color. So those are the two color identifications with the acids and bases by using methyl orange synthetic indicator. And by coming to phenolphthalein, phenolphthalein is a colorless indicator. When you add this colorless phenolphthalein indicator few drops to acid, it won't show any color change in the acid. When you add the same phenolphthalein few drops to base, immediately the color of base or alkali changes to pink color. We can see in the picture here. Pink color it appeared when few drops of phenolphthalein is added to alkali. So in this way, phenolphthalein will show color change with bases or alkalis only. It won't show any color change with acids. So this is about synthetic indicators. Okay, children. Now, based upon these indicators, we are going to have small assessment. So, let us recollect once the point what we have discussed about the indicators. What are indicators? The chemical substances which shows color changes with acids and bases, or we can say in the other way, the chemical substances which are used for the identification of acids and bases in the laboratory are called indicators. So based on the sources, these indicators are classified into two types. What are those? Natural indicators and yes, synthetic indicators. Natural indicators are those which are extracted from natural substances. Example for those, litmus, yes, turmeric, chain arrows. These are natural indicators. So in this litmus is extracted from lichen, which is having sources like algae and fungi. So this litmus is available in two colors, blue and red. This blue litmus shows color change with acids and turns into red color. And red litmus shows its color change with bases and turns into red color. That is one. Next one, turmeric. Turmeric is a domestic purpose use substance only, we know that. It is in yellow color. This shows its color change only with bases and turns into red color. It won't show any color change with acids. Next one, chain arrows. Chain arrows is extracted from the flowers, chain arrows flowers, and it will be light pink color. Its solution will be light pink color. When you add few drops of this chain arrows solution into an acid, the color of acid immediately turns into dark pink or magenta color. When you add these few drops of chain arrows solution into a base, its color changes to light green color. Okay, these are natural indicators. What are synthetic indicators? Phenolphthalein and methyl orange. These indicators are prepared in the laboratory and hence are called synthetic indicators. Methyl orange is in orange color solution. If you add this to an acid, it changes its color to dark pink or red color. If you add the same to a base, its color will be changed to yellow color. What about phenolphthalein? It is a colorless liquid. When you add this phenolphthalein to an acid, it won't show any color change. If you add the same to a base, its color changes to pink color. So based upon these points, we are going to see now some questions. Okay, be ready children. Try to answer these questions. Try to test yourself. So the first question, which of the following statements is correct? Acid turns blue litmus red. Is it correct? Next one, base turns white litmus blue. Acid turns red litmus blue. Base turns blue litmus red. So out of these, which statement is correct about litmus action towards acid base, children? Check it one by one. Acid turns blue litmus red. Yes. Blue litmus paper when dipped into acid solution, immediately its color changes to red color. So first statement is correct. Let us check the remaining also. Base turns white litmus. So white litmus itself it is not available. Litmus is available only in two color stores. So it is wrong. Next one. Acid turns red litmus blue. No, it is wrong. It turns red litmus blue only. Base turns blue litmus red. Yes. Bases turn blue litmus red. It is also correct. Sorry. Red litmus blue. Bases turn red litmus blue. It is also wrong. Now only one is correct. That is acids turn blue litmus red. That is the only correct answer here. A is correct. Let's go to next question. That is the substance that are used to test whether a substance is acidic or basic are called. So what are those substances called? Is it acid or base or salt or indicator? So which is correct statement, children? The substance that are used to I find whether the given substance is acidic or basic are called, yes, it is indicators. We call them indicator or indicators. The substances which are used to identify the given substances as whether they are acids or bases are called indicators. Next question. Phenolphthalein turns dash in acidic and neutral solutions. So what is the color of phenolphthalein solution in the acidic and neutral solutions? Is it colorless or pink or red or green? What is the color of phenolphthalein solution in the acidic solutions? Yes, while discussing about phenolphthalein we told it won't show any color change with acid solutions. What is the color of phenolphthalein? It is a colorless solution. So when you add this phenolphthalein to acids, there will be no change in the color. So it will be colorless only. Even with the neutral solutions also, it won't show any change in its color. So phenolphthalein turns colorless only. It remains colorless only in the acidic solutions or neutral solutions. Okay. Next one. The color of methyl orange indicator changes to dash with pink basic solution. So the color of methyl orange with basic solution. What is the color of methyl orange? It is in orange color. So it shows different colors with acids and bases. They're asking here, how does it change its color with the basic solution? See options: red, yellow, orange, or colorless. What is that color, children? Yes, methyl orange changes its color to yellow on mixing with basic solutions. Color changes to yellow. Find the natural indicator from the following. So identify the natural indicator among these: China rose, sodium chloride, phenolphthalein, methyl orange. So which of these is the natural indicator, children? What did we say natural indicator means? The substance which is extracted from natural sources or natural substances. And if it is used for identifying the acids and bases, then it is called natural indicator. So what did we say natural indicators? Examples: litmus, turmeric, and even China rose also. Okay, China rose is one of the natural indicators. What about the remaining? Let us see. Sodium chloride. It is not at all a indicator. It is a salt. It is a chemical substance. That's it. It is not used as indicator. And phenolphthalein and methyl orange. These two are synthetic indicators, not natural indicators, because these two are prepared in the laboratory. Of course, these are indicators only, but they are synthetic indicators. So only one is China rose, that is a natural indicator among these all. Okay, children, this is about indicators and their classification, how they show color changes with acids and bases. Okay, thank you for watching our video. Please subscribe our channel and visit our website, that is www.aimstoday.in, for latest updates and recorded videos. Thank you.